CL400 or Control Language 400 is the native language of the AS400 through which users interact with the system. CL commands are similar to that of the PC-DOS commands used in the PC environment. All activities on the AS400 can be controlled through CL400 commands. There are more than 1,000 commands that support a wide variety of functions, such as for administering the system, working with objects, managing users, sending and receiving messages, etc. You can enter CL commands in two ways. Either type them individually on the command line, or you can group the required CL commands into a CL group, compile it, and then run the entire program. However, CL is not a high-level language. CL, however, has certain limitations that make it unsuitable for developing business applications. CL programs can only read from database files. Update and add operations are not allowed. Also, only a single file can be opened in any CL program. It could be a database file, or display file, or printer file. CL programs do not support subfiles for application displays. When a CL program is compiled, we get an AS400 object which is of the type *PGM. The CL program object runs much faster than a group of CL commands entered individually at the command prompt. Let us look at a CL command CRTPF, that is, create physical file. Any command can be split into two parts. The first part is a verb that specifies an action to be performed, such as CRT for create. The second part specifies an object, such as PF for physical file, on which the action is to be performed. The maximum length of any CL command is 10 characters. The verb part of the command consists of 3 characters, while objects are represented from 1 to 7 characters. Here are some examples of the common verbs that are used in CL commands: change, create, declare, override, save, start. Similarly, for objects you can have authority, diskette, file, library, member, object. Let us take a look at the CL command syntax. The square brackets indicate that the particular parameter is optional. First, we have the question mark that is used for prompting for parameters. We will look at this in a later section. The second parameter is a label name that is used to identify a CL statement for branching to in CL programs. Here we have the move object command that is used to move an object from one library to another. Let us look at the parameters. We have a label name objmv. The length of a label name can be from 1 to 10 characters, and a colon must immediately follow a label name. A label name is a character string that has to start with one of the letters of the alphabet or the dollar, hash, or @ symbols. The remaining characters can be any of A to Z, 0 to 9, dollar, hash, @ underscore, or a period. The next entry is the name of the command itself. Move object followed by the command parameters. The first parameter that we have is obj, that is used to identify the object to be moved. In this case, cust98. obj is called the keyword and cust98 is the value for the keyword. We specify the remaining parameters in a similar manner. CL commands can be written in three forms: the keyword form, the positional form, and the combined form. Let us see how the display object description command can be represented in the three different forms. In the keyword form, each command parameter value is preceded by its keyword. In positional form, keywords are not used. Instead, each of the parameters are to be specified in the exact order which has been defined for the command. The combined form is a combination of the keyword and positional forms. You can begin by specifying the parameters in the positional form and then switch over to the keyword form. Let us look at a more complex command, send message, that is used to send immediate messages to one or more message queues. Here, the message string that is to be sent is specified with the message parameter. It should be enclosed within single quotes. The plus sign is used to indicate that the rest of the command is continued on the next line. The second parameter, toMessageQueue, identifies the message queue to which the message is to be sent. Here we have specified *sysopr, the system operator message queue. This is a predefined value. All predefined values begin with a star. Comments should always be enclosed within the character shown here. Let us now take a look at the CL program structure. A CL program is divided into four sections. The first section is known as the program information section. This section identifies the program name, author name, date of completion of the program, and the purpose of the program. The second section that immediately follows the program information section is known as the program linkage section. This section always contains only one CL command, the PGM command, that defines the beginning boundary of a CL program. The third section that follows the program information section is known as the program declaration section. In this section, we declare the variables and files that will be used in a CL program with the DCL and DCLF commands. The last section is known as the procedure section. This section contains CL commands that perform the necessary functions. Here we end the program with the end PGM command. The compiler ignores any statements that are included beyond this point. We will now look at the declare variable and declare file commands. The declare variable command defines the variables that will be used in the program. We specify the variable name, its type, length, and initial value, if any, that is to be stored in the variable. The first parameter in the declare variable command is var. Here you specify the name of the variable with an ampersand followed by a variable name which can be from 1 to 10 characters. The variable names should always be preceded by the ampersand sign. The second parameter is type, that specifies whether the variable is to hold character, numeric, or logical data. We use *char for character data, *dec for decimal data, and *lgl for logical data. The len parameter is used to specify the size of the variable. Character variables can have a maximum length of 9999 characters. The default length is 32. Here we are declaring a variable cname of type character and length 20. For numeric variables, the maximum length is 15 digits, out of which you can specify a maximum of 9 digits for the decimal portion. The default is 15 digits, out of which 5 digits are for the decimal portion. Here, amount is a variable of type decimal having a total length of 9 with 2 digits for the decimal positions. A logical variable can have a maximum length of 1, which is also the default length. Here we have declared a logical variable status. The value parameter is used to assign an initial value to a variable. It is an optional parameter. Let us now move on to the declare file command. The declare file command makes a display file or a database file available for processing in a CL program. Let us look at a simple program. The declare file command identifies the display file cust.dspf that we will be using in our program. A qualified name identifies the library as cust.lib. The send receive file command sends the record format cust.fmt in the display file to the workstation and reads the input data entered by the user. Alternatively, we could also use the send file command and receive file command separately. The send file command sends a record format to the display and is used only with a display file. Similarly, the receive file command reads a record from a display or a database file. The wait parameter is a useful feature that allows our program to continue processing without waiting for the user to finish inputting the data. When *yes is specified, the program waits until the user presses a function key or the enter key and then continues. When *no is used, the program can continue and stops when a wait statement is encountered. It will now proceed further only when the user presses either a function key or the enter key. The change variable command is used to assign a new value to a variable. You can also use the change variable command to convert decimal data to character data and vice versa. We define a decimal variable, amount, with length of 7 and 2 decimal positions. Camount is a character variable with a length of 10 characters. Next we come to the change variable command. The first parameter in the change variable command names the variable camount to which a value is to be assigned. The second parameter, value, contains the variable amount whose value will be assigned to the variable camount. The goto command is used for unconditional branching. It causes the program to skip to the line identified by the label mentioned in the command label parameter. Conditional branching is achieved through the if-then-else construct. The if command defines a condition through a relational expression. The relational expression consists of two operands and a relational operator. Operands can be constants, variables, or other expressions. The relational operator could be less than or equal to, greater than or equal to, not less than, not greater than, not equal to, and, or, not. In this example, if the value of option is equal to 1, then a program named reports is called. Otherwise, control passes to the else statement where another program inquiry is called. You can also have nested if structures. Let us take a look at an example. Here, the first condition is checked to see if option is equal to 1. If the first condition is true, then the second condition is checked to see whether A equals 2. If this condition also is true, then the program reports is called. The same if statement, when written in the positional form, is much easier to interpret than when it is coded in the keyword form. The else statement always follows the if statement and is executed only when the condition in the if statement is false. Let us now take a look at another example. First, the condition in the if statement is checked to see whether option is equal to 1. If it is, the program inquiry is called. If the condition is false, the else statement gets executed where the value of option is checked once again. If the condition is true, the reports program is called. CL uses the do and end do commands to extend the usefulness of the if-else statements. The do and do commands can be used to group a set of CL commands so that they are executed together.
Let us see how to pass control from one CL program to another. CL provides two methods for achieving this, the call and the transfer control commands. Let us look at the call command. Say our main program is executing. When it reaches the call statement, the system will place the current program on the jobs program stack. It then passes control to the program identified on the call command. The main program is referred to as the calling program, and the program to which control is passed is called the calling program. The call program starts executing, and when it finishes, it will return control back to the called program.
Next, let us look at the concatenate operator used to combine two strings into a single string. You have three concatenate operators: star cat, star bcat, and star tcat. cname1 is a character variable with length of 12 containing the string bitmappers. cname2 is another character variable with a length of 10 and value education. Let us see what happens when we use the different operators to concatenate the two strings. If we use the star cat operator, the result variable will contain the two strings combined exactly as they are without any modifications. With star tcat, all the trailing blanks in both the strings will be removed. *bcat also removes all the trailing blanks in both the strings, but at the same time inserts a single blank between them. Let us take a look at a CL program which includes all the commands we have studied so far. This CL program will check the company ID. If the company ID is 1234, it will send the message Customer ID 1234 ABC Limited payment has been received to the ACTDEPT message queue. Otherwise, the message Customer ID 5678 XYZ Private Limited payment is overdue by 45 days is sent to the ACTDEPT message queue. The program starts with the PGM statement. Next, we declare a database file custpf and the variable cdays. The receive file command is used to read a record from the database file custpf. The value of the days field from the database file is changed to a character value so that it can be used in the send message command and stored in the variable cdays. The value of customer ID is checked, and if it is equal to 1234, then the message Company ID 1234 ABC Limited payment has been received is sent to the message queue ACTDEPT. Otherwise, the message Company ID 5678 XYZ Private Limited payment is overdue by 45 days is sent to the message queue ACTDEPT. Let us move on to menus. AS400 menus provide a very easy to use interface for a user. We can create menus on the AS400 which are identical to the existing menus. The advantage of using menus instead of programs is that the user is already familiar with the way the AS400 menus work. Menus are accessed using the go command rather than the call command used for programs and also does not require parameters. The go command has a return point parameter which can be set to *yes or *no. You can specify a return point. Return codes can be used which simplify program logic. You can create two types of menus: display file menus that are supported by display files and program menus that are supported by programs. You can design display file menus using the Screen Design aid. The display file defines the way the menu looks. The message file defines the actions to be taken when a menu option is selected by the user. The program menus are supported by programs that defines the action to be taken when a menu option is selected. A display file is normally used to define the way the menu looks. Let us see how menus work. From the main menu, let us say Go Major. By default, the return point has a value of *yes. From the major menu, let us say Go Security with return point set to *no. From the security menu, we say Go System with return point set to *no. Here, if we press the F3 key, we will return to the major menu. From the major menu, if we press the F3 key, we will return not to the major menu but to the main menu, as the return point had been set to no when we were in the major menu. Pressing the F12 key from any menu will take us back to the previous menu, while F16 will take us to our initial menu. Let us see how to create a program menu. First of all, we write a program to perform the desired functions. The program should have three parameters which are used to pass parameters between the menu and the program. The first two parameters are used to pass the menu name and the menu library name to the program. The third parameter is used by the program to pass a return value back to the menu object when the program ends. The return code can take on one of four possible hexadecimal values: FFFF, FFFE, FFFC, and 0000. The return code specifies where control is to be passed when the program completes execution. FFFF and FFFE both end the program. A value of FFFC transfers control to the user's initial program. A value of 0000 returns to the menu display. When the return code is FFFF, the point to which control returns depends on the value of return point. Return point has no effect on the return code FFFE. CL does not support hexadecimal values, and hence we code these values as 2-byte character variables. Declare the display file cus.dspf. We then use the send receive file command to display the customer master menu. We check the option entered by the user and accordingly call the respective HLL program. If the user presses function key F16, he is returned to the initial menu. This is achieved by assigning a value of FFFC to the variable that is used for the return value using the change variable command. If the user presses the F3 key, a value of FFFF is assigned to the return value variable and the user will be taken back to the previous menu he was working with or the one before that, depending on the value of return point. If the user presses the F12 key, a value of FFFE is assigned to the return value variable and the user goes back to his previous menu. This is what the display screen in the cus.dspf file looks like. This file should exist before the program is compiled. The next step is to create the menu object using the create menu command. In the menu parameter, we specify a name for the menu object that is being created. In the type parameter, we specify that it is a program menu. The program parameter is used to associate the program that is to be executed with the menu object. Normally, we use the same name for the program as the menu object, as is indicated by the value *menu specified here. However, you can also use a different name. You can also specify a library that is to be made the current library while this menu is running in the current library parameter. In the product library parameter, we can specify any product libraries that are to be added to the jobs library list while the menu is running. Now, to run a menu, we can use the go command and specify the name of the menu. This will display our menu. With this we come to the end of this chapter. In this chapter we studied control language and its syntax. We also saw the declare variable and declare file commands, the change variable command, the if then else and do structures. Finally, we looked at program menus.